Okay, now we're going to talk about a scheduler operator that can be used in conjunction with a bunch of different reactive types, and that's going to be the bounded elastic scheduler. And this, as always, is factored out from ParallelFlux, so it could be used with flux and mono classes as well. So the idea of this particular operator is to dynamically create a bounded number of executor service-based workers. So it's a pool that can grow and shrink. And it returns a new scheduler, the scheduler bounded elastic operation returns a new scheduler that's suited for I/O-bound work, whereas other schedulers we've looked at, like Parallel, were not suited for I/O-bound work. In particular, it's optimized for blocking tasks that will block on I/O. And it's not, you can use it for CPU-bound tasks, but it's probably better to use a different scheduler like Parallel, because Parallel has a fixed number of threads, which works well for compute-bound tasks and won't grow and shrink. Bounded elastic is really intended for things that can grow and shrink, but CPU-bound tasks don't do that. It'll either start a new thread or it'll reuse an idle one from a cache that it keeps. And the underlying threads in this cache will be evicted if they're idle for more than 60 seconds. So that way the thing can grow and shrink based on bursty behavior by the client. The overall goal here is to maximize the utilization of CPU cores by having everything running and being able to enable things that block to not chew up cores and prevent other things from making progress. New threads will be spawned behind the scenes dynamically up to a certain bound in order to make sure things keep running. However, this is not an unbounded model. It's bounded by a cap, and by default, the cap is 10 times the number of available CPU cores. So if you have an 8-core machine, you can have up to 80 threads. And I think you can change that value if you want to. And there's also a bound on the number of submissions that are queued and deferred on each of these backing threads, which is by default 100,000 tasks. So if you go beyond that, then it'll stop. But if you have a lot of threads and a lot of queuing and you're still filling up, you have a bigger problem. You have a flow control problem at that point. We typically use bounded elastic for making network calls, file I/O, database operations, things that might block. And in particular, we're going to see that we have an example we'll look at where we download and store images using this particular model. Behind the scenes, the bounded elastic threads are so-called daemon threads, which means that if the main application thread goes away and there's no more user threads left, these threads will be shut down also, even if they're not done. There's an operator that's defined in the schedulers I/O mechanism in RxJava that works like bounded elastic. And the Java common fork join pool is similar, especially when you combine it with the managed blocker mechanism. That's beyond the scope of this class, but if you take one of the other courses I teach, at some point we'll cover that in more detail there. So that's the end of the overview of the bounded elastic scheduler.